Good evening and welcome everyone. On behalf of the Department of Mathematics at Wilson College, I welcome each one of you to the day two of the IIT JAM Mathematics Workshop. Today, we'll be having sessions by two resource persons. So, for the first session, I would like to invite Dr. Dipak S. Jadhav. Sir is an associate professor in the Department of Mathematics at Srimati CHM College, Ulhasnagar. He's a very good and dedicated teacher, and I'm saying it out of my personal experience because I'm one of his students uh, during my BSc graduation. I've always known him to be a person who is passionate about mathematics. So it is really a privilege to have Sir as a resource person for this workshop. I now invite Sir to begin his session. Welcome, Sir.
Yeah. Thank you, Tina.
Have made you co-host. You can share your screen or
Okay,
unmute
okay. Yes.
yourself.
Yeah. Is my screen visible to all of you?
Ye- yes, sir. It is
Okay.
visible.
So thank you, Tina, for the warm introduction. So I'll be dealing with the topics from real analysis. Basically, the two topics that I'm going to deal, sequences and series. So I'll be conducting few more sessions. So today we will spend some time on understanding sequences, recalling few results, and we'll try to solve some problems from past in paper. Am I audible to all of you?
Yes, sir.
Okay. Okay. So sequences is basically a function defined on set of natural numbers, taking values in either set of real numbers or set of complex number. If it's taking values in set of real numbers, we call it as real sequences. And if it takes values in complex number, we call it as complex sequences. Once you learn sequences, the first thing that comes to mind is the concept of convergent sequences. So, all of you already studied this concept. A sequence is said to be convergent if for every epsilon there is some n naught, such that distance between sequence nth term of a sequence and its limit less than epsilon for all n greater than equal to n naught. So sequence is normally denoted by xn, and we say xn converges to p. That means p is limit of xn. So sequences, this topic basically deals with studying convergent sequences. So we study lots of results related to convergent sequences. The first result that we come across while studying this chapter is whenever a sequence converges, it converges to unique limit. So uniqueness of limit of a sequence means you cannot have a sequence converging to two different real numbers. Then we also study something called as bounded sequences. A sequence is said to be bounded if you have some real number m such that mod of xn less than equal to n for all n in n. Means every term of that sequence is bounded by a large number, fixed positive large number. Then there is a relationship between convergent sequence and bounded sequences. Every convergent sequence is always bounded, but not conversely. Means every bounded sequence need not be convergent. For example, can take xn is equal to minus 1 raised to n for all n in n. So this is a bounded sequence but not convergent. So routine example. Then we study results like this. Xn converges to p implies mod xn converges to mod p. Again, converse of the statement need not be true. Which is not true. Nevertheless, we have the result like xn going to 0 if and only if mod of xn going to 0. Means if p is 0, then converse of the above statement is also true. Then we study something called as algebra of sequences. Means if you have two convergent sequences, their addition is also convergent and converges to addition of their limits. Same thing is also true for subtraction of two sequences. Scalar times a sequence, multiplication of two sequences, and division quotient of two sequences whenever they make sense. So those results, I hope all of you are aware of algebra of sequences. Then we have few more results like if you have a sequence xn converging to p and you know that p is strictly greater than 0, then there exists some n naught belongs to n such that xn is strictly greater than 0 for all n greater than equal to n naught. Means you have a stage after which all terms of your sequence are strictly positive. Another result, if you have a sequence xn which is bounded and you have another sequence yn tending towards 0, then what can we say about the product xn into yn? The product goes to 0. If we have two sequences such that xn is less than equal to yn for all n in n, then the same relation is also holds for their limits. Limit of xn less than equal to limit of yn. Then we study a famous theorem like squeeze theorem, sometimes also called as sandwich theorem. Related to sequences, we have three sequences xn, yn, and zn. Satisfying a relationship xn less than equal to yn less than equal to zn for all n in n. And you also know that xn converges to L, Zn also converges to L. Then Yn is a convergent sequence and converges to L. That's a sandwich theorem. Then there are some special examples of convergent sequences. Like the first one of them is if you have a greater than 0, then a raised to 1 by n is a sequence. Like a, the second term is a raised to 1 by 2, Third term is a raised to 1 by 3, a raised to 1 by 4, and so on. So we must have seen that this sequence is a convergent sequence. And where does it converges? It converges to 1. Similar kind of result we have also seen for this sequence. Sequence n raised to 1 by n. That is 1, 2 raised to 1 by 2, 3 raised to 1 by 3, 4 raised to 1 by 4, and so on. Anybody knows the limit of the sequence? Limit of the sequence is again 1. So these are the third sequence in the category of special example is if you have -1 less than a less than 1, then the sequence a raised to n, like a square, and so on. We already know that the sequence goes to 0. The sequence goes to 0. So proofs of these three statements is a routine proofs which are you have already studied in your lower standard, possibly in FY or SY. Apart from this, in the topic sequences, we also study something called as monotonic sequences. Like if you have a sequence satisfying this condition, xn less than or equal to xn plus 1 for all n in n, then such a sequence is called as monotonic increasing sequence. And if you have exactly reverse condition for all n in n, then it is monotonic decreasing sequence. Result related to them is every monotonic, and additionally one more hypothesis, bounded sequence is convergent. Apart from this, you have also done something called as Cauchy sequences. Sequence xn is Cauchy if you have xn minus xm is less than epsilon for all n and m greater than equal to n naught. Means after some stage, distance between any two terms of the sequence is arbitrarily small. Sequence is called as Cauchy sequence. And there's a relationship between convergent sequence and Cauchy sequence is that every convergent sequence is always Cauchy. And the converse of the statement in general it is not true, but we do have something like every Cauchy sequence is convergent in R. Means instead of observing sequences in a subset of R, if you observe that sequence in a full
Uh,
set of real numbers,
Sorry
then
to interrupt, but
yeah.
actually, I just missed a definition above. Uh,
Which definition, madam? Yeah.
bounded series, bounded sequence.
Bounded sequence is that a sequence is bounded if you have a fixed number m such that absolute value of every term of your sequence is less than or equal to that m. Then we say that sequence is a bounded sequence.
Okay, sir. Thank you, sir.
Yeah. So converse of every Cauchy sequence is convergent holds only in R. For example, if you take a sequence 1 by n in open interval 0, 1, then xn is Cauchy, then xn is Cauchy but not convergent. But if you take the same sequence in R, then it is convergent. We all know that it goes to 0, and 0 is a real number. So these are all concepts that we have learned about sequences. You might have also came across something called as subsequence. A sequence, and you have a subsequence of that sequence. There's a definition for the subsequence of a sequence, but the required result is that if a sequence is convergent, then every subsequence of a convergent sequence is always convergent. So every sequence of convergent sequences convergent, but not conversely. But not conversely. Converse of the statement is not means if every subsequence converges, then that does not possibly you may have different limits. Okay, so with this small introduction of the topic, let us look at your problem. Yeah, is the problem visible to all of you?
Yes, sir.
Can you try computing the limit of sequence? If you observe this jam question papers of mathematics, you will find plenty of problems based on finding limit of sequence. Sometimes the terms of the sequence
It's
are given
3.
direct. Yeah.
Limit of sequence is 3.
Okay. Okay. Good. Yes. How many of you able to compute the limit? Okay. So yes. So for those who seeks answer, let us do it quickly. Can break this. The numerator using law of indices, and then you divide by 3 raised to n to the numerator and denominator, you end up getting something like this. And then we use the result of spatial sequences. If your a is between -1 and 1, then a raised to n, the sequence goes to 0. So using that result, numerator will approach towards 0 plus 3, and denominator will approach towards 0 plus 1. So answer is 3. Yeah, very good. Let's look at the next. Is the next problem visible to all of you? Yeah. Try computing. What do you feel? Is it convergent? three of the options, see there are four options. Three of them says it converges, and one of the options says does not converge. So when we try attempting such a problem, we want to seek the limit of the sequence. So let's try to find limit of the sequence. At a first stage, we don't know whether it exists or does not exist. But let us try to find limit of the sequence. This is the sequence. Okay, so one of the participant has given answer 1/4 and another participant has given answer 1/2. Okay, so two of them has given 1/2. Let's see, when I see some identity, do I have any identity related to this? 1 minus cos theta, any trigonometric identity you have learned possibly in 11th standard. So 1 minus cos theta is 2 sine square theta by 2. So this is a hint. Try using this hint. Try to compute the limit of the sequence. So using this hint, this will coming out to be 2 sine square 1/2 into 2 raised to n. Yeah. So we'll get something like this. Limit 2 is common out. Sine square 1/2 raised to n plus 1 on 1 by multiply and divide by this 1 upon 2 raised to n plus 1 square. And see whether you get the required answer. So we know that this limit is 1. And see what you get here. Answer is 1/2. And try computing the answer. Answer is 1/2. Is it okay for all of you? Can we move on to next question?
Yes, sir.
Yes, sir.
Okay. Observe this question. Though this question does not looks like directly computing limit of a sequence, or but we want to compute, there is some say its greatest lower bound. So if you observe the set, e raised to n plus 2 raised to n whole raised to 1 by n belongs to n. So it looks like a first term is e plus 2, second term is e square plus 2 square raised to 1/2, and so on. So let us call this, let us denote this term by xn. So we'll have xn is equal to e raised to n plus 2 raised to n whole raised to 1 by n. me ask a question. Is it possible to compute limit of the sequence?
Yes, sir.
Yeah. So what I asking is this. How will you compute the limit of the sequence?
Yes, sir, and it is 1.
It is 1. So suppose L is limit of the sequence.
No, sir. It is E.
Yeah, is E. Yes. Limit of the sequence is E. Let us see how. Suppose you denote limit of the sequence by L. Take log on both sides. There's a usual trick to handle such kind of limits. And the log as being a continuous function, it goes inside the limit. And after simplification, you'll end up getting something like this. Then we are aware that this is looks like this. Log of e raised to n plus 2 raised to n divided by n. So this is something called as infinity by infinity form. So all of you must have learned something called as L'Hopital rule, which is applicable when the value of limit is either 0 by 0 or infinity by infinity, and the terms in the numerator and denominator are differentiable functions. So let us apply that rule, because here we know that numerator is also going towards infinity as n tends to infinity, and denominator is also going towards infinity. So this is infinity by infinity kind of limit. So you get something like this. You differentiate the numerator, and then you differentiate the denominator. Derivative of denominator is n, sorry, 1. We are differentiating with respect to variable, and the variable is n. So here we get something like this. E raised to n plus 2 raised to n log 2 upon e raised to n plus 2 raised to n. Then as usual trick, which we have already seen in first problem, we know the relationship between e and 2, which is bigger. E is bigger, so divide by e raised to n. 1 plus 2 by e raised to n into log 2 upon 1 plus 2 by e raised to n. And by the 2 by e is less than 1, so 2 by e whole raised to n will go to 0. So we'll have limit is 1. So log L is 1, so L is E. So somehow we computed limit of the sequence. But the problem says we want to compute greatest lower bound of the set. So then that is e raised to n plus 2 raised to n whole raised to 1 by n goes to E as n tends to infinity. But we want greatest lower bound of this set. So how do we go ahead now? On the real
Sir,
line,
because
yes, please. Yeah.
Because sequence is convergent, it goes to unique limit, then its greatest lower bound and least upper bound are equal to that limit.
Okay, so let us consider the sequence. Xn is equal to minus 1 raised to n upon n for all n in n. What are the terms of the sequence? First term is n is equal to 1, that is minus 1. Second term is 1 by 2. Third term is minus 1 by 3. Fourth term is 1 by 4 minus 1 by 5. Is it okay, the sequence? Yeah. Let us plot it on real line. Anybody knows the limit of this sequence? We know that
0.
xn goes to 0. Yeah, very good. 0. What is the first term of the sequence? Minus 1 here. Second term, 1 by 2 here. Third term, minus 1 by 3 somewhere here. Next term, 1 by 4 here. All of you agree with this?
Yes.
Yeah.
Yes.
Now, what is the greatest lower bound of this set? Is it 0?
-1.
-1.
Yeah, very good. It's -1. It's not 0. That's not a limit of that sequence. So if your sequence converges, then we can't say the greatest lower bound of that set which contains all terms of your sequence is the limit of that sequence. Unless and until we are sure about whether that sequence is monotonic, whether it is increasing or whether it is decreasing. Sequence may approach towards limit of that sequence either from either side. It may approach towards limit from positive side on the right side, or maybe from left hand side, or maybe both side. You can observe in this case there are infinitely many terms of the sequence are on the right of 0 and infinitely many terms of the sequence are on the left of 0. But neither its greatest lower bound is 0 or least upper bound is 0. In fact, least upper bound of this set is half. So none of them matches with limit. So just by computing limit, we can't say greatest lower bound of this set is E. Is it okay now?
Yes, sir.
Yeah. So that means we need something else.
Sir, can we check that is it monotonic or not?
You can check it whether it is increasing or decreasing. But in that case, you need to compare the two terms, xn and xn plus 1. Xn is what, e raised to n plus 2 raised to n whole raised to 1 by n, and xn plus 1 is e raised to n plus 1. This comparison you can do, but may not be easy to compare these two terms. What I suggest, let us observe. What is this e raised to n plus 2 raised to n? So e raised to n and e raised to n plus 2 raised to n. What is the relation between this? Which one is bigger and which one is smaller? Yeah.
E raised to n plus 2 raised to n is bigger.
Bigger. Yeah, because there is something positive is getting added. So I can say e raised to n, in fact, it is strictly bigger. It's not even equal at any n. Yeah, is it okay?
Yes, sir.
Yeah, you take the nth root on both sides. What you will get on the left?
E.
So E, and the right hand side, e raised to n plus 2 raised to n whole raised to 1 by n. That's your nth term of your sequence. Would you see?
Yes, sir.
So now from this, is it possible to say something about greatest lower bound? So we haven't
E
checked.
is the greatest lower bound, sir.
Yes. We haven't checked whether it is monotonic, whether it is increasing, whether it is decreasing. But we have compared every term of the sequence with E. So we observe that every term of the sequence is strictly bigger than E. And we have already noted E is a limit of that sequence. So both these things are equally important to say greatest lower bound of this set is E. Suppose we were knowing only this. We were knowing only this. We were not knowing limit of that sequence. So with this in our mind, E less than xn for all n belongs to n. Does that sufficient to imply E is the greatest lower bound?
Yes, sir.
No,
No, sir.
we could also
Yeah,
say it is a lower bound.
yeah. It is just a lower bound. The statement says it is just a lower bound. This statement does not say it is a greatest lower bound. Are you able to see this? This says only lower
So,
bound.
sir, is it necessary to find the limit every time?
Means for finding greatest lower bound, you mean to say? With knowing the statement, every term of your sequence is greater than E. Is it sufficient to conclude that E is a greatest lower bound of this set?
No, sir.
No, no, because E is just a lower bound. Something bigger than E may be a greatest lower bound. But we also know that limit of the sequence is E. We also know that limit of the sequence is E. How does this help to say that E is the greatest lower bound of this sequence? Yeah. Did you understood my question? We have
Every
concluded.
term in the sequence is less than E, and E is the limit. So the sequence must approach E from the right side of the real line. So E must be the greatest lower bound.
Yeah. So on the real line here, if you have E, then every term of your sequence is on the right hand side of E, and the sequence is converging to E. So whatever small neighborhood of E you consider, in that neighborhood you'll always find terms of your sequence. So anything bigger than E cannot be a lower bound of this set. So that's why E is the greatest lower bound. That's why E is the greatest lower bound. Let me repeat. This statement says E is a lower bound. That means every term of your sequence is bigger than E. And we have computed the limit of that sequence that says that your sequence xn approach towards E. That means every neighborhood of E contains terms of your sequence. So anything bigger than E cannot be a lower bound of this set. That's why E is a greatest lower bound of this set. Is that okay for all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Good.
Sir, then is it necessary to find the limit of the sequence in every question for finding the greatest lower bound or least upper bound?
It's not necessary because we have checked here. See, this is a sequence. Its limit does not help to compute greatest lower bound and least upper bound because the limit is different and greatest lower bound is different and least upper bound is also different.
Sir, I have a
Is that
question.
okay? Yeah.
Is it what if we take a sequence which is we don't know what the it is monotonic or not? How to check if we can't find the limit?
Then you need to consider either these differences. You need to consider xn plus 1 minus xn. You need to simplify this. If you can able to prove this is greater than or equal to 0, then you say it is monotonic increasing. If you can able to prove it is less than or equal to 0, then it is monotonic decreasing. Sometimes observing a relationship between xn plus 1 and xn, it's not easy. Try computing this difference.
Yes,
When we
sir. I
consider
am
this
asking for
difference,
it.
yeah. So when you consider difference, then it might be easy to check whether it is greater than 0 or less than 0. Is that okay?
Thank you, sir.
Can you try this question? Here again, now the slightly different pattern of a sequence. The terms of the sequence are defined by using recursion. An plus 1 is defined by means of the previous term, an. So a1 is 1, an plus 1 is an plus an square. So which of the four options are? Now, can
First
you,
one, sir.
yeah,
First and second.
first and second, yeah. Now, can you say something about monotonicity of the sequence?
Yes, sir. It is monotonically increasing.
Yeah, very good. Because the sequence starts at 1. An plus 1 is something is getting added to an. And that something is nothing but positive. Positive things is getting added to previous term. So your next term is always bigger than previous term. So your sequence is monotonic increasing. Monotonic increasing. Is it bounded sequence?
No, sir.
No, it's
Bounded
not.
below.
Yeah,
It is bounded below, sir.
Yes. Can you repeat? Yeah, it is bounded below, but not bounded above. So the B is true because an is approaching towards infinity. So 1 upon an will approach towards 0. And what about A? You can actually compute A4 by using this recursive definition of a sequence, and you can verify option A. So A is also correct. A is also correct. Let's have quick, easy problem. Yeah. Can you tell me the answer? There are two sequences, AN and BN. Now 4 options. AN is convergent, BN is bounded. So we are talking about convergence or not
C, sir.
convergence of, yeah, which? C.
Option C.
Yeah, yes,
C.
correct. Yeah. What is the limit of AN? Where does AN converges?
E.
E.
E. Correct. And why BN is
N
not
is
bounded?
bounded.
Cos is bounded plus the n is unbounded, so it will be unbounded.
Yeah, this is bounded, but N is unbounded. So the product is unbounded. Very good. What about this?
C.
AN is not convergent, but BN is convergent.
B.
C, sir.
C. C.
C. C. Okay. Yeah. Yes. AN is not convergent, but BN is convergent. Where does BN converges?
0.
Yeah. Yes. Correct. BN converges to 0. What about this? We have already seen the sequence. N raised to 1 by N. 1, 2 raised to half, 3 raised to 1 by 3, 4 raised to 1 by 4, and so on. We already noted the sequence is convergent and converges to 1.
1.
Yeah. So here it says divergent, divergent. So these two options are ruled out. So either option A or option B.
B.
Bounded convergent but not monotone.
Okay. So there is a we need to just check whether it is monotone or not monotone. If it is monotone, then option B. If it is not monotone, then option A. So will you check whether it is monotone or not monotone?
Sir, the first term of the sequence is 1 and root of 2 is approximately 1.414. It is increasing, but the limit is 1, so it will increase and decrease, so it is not monotone.
Yes, that's a good observation. On the real line, if I plot, this is the first term, second term is somewhere here, 1.41 approximately. That's root 2. And the limit is 1, so it has to again come back to 1. So that's why it is not monotone. But there is another way by which you can also see the, if I consider this function, f of x is equal to x raised to 1 by x. This function I have considered by using the nth term of the sequence. Then can you compute its derivative? Is it possible to compute its derivative? Is it differentiable function? Yeah.
Yes, sir.
Okay. So some of you feel yes, some of you feel no.
Yes, sir.
Okay. So all of you feel yes. So what is its derivative? How will you compute derivative of such function?
We can take the logarithm and then
Yeah, yes, very good. So if you call this as u, then take the log. Log u is 1 by x into log x, and then you compute the derivative. By chain rule, derivative of left hand side is 1 by u into u dash. On the right hand side, 1 by x into 1 by x plus log x into minus 1 by x square. You need to apply u into v rule. So you get something like this. U dash is equal to u times 1 by x square into 1 minus log x. Is it okay?
yes, sir.
Yes, sir.
Yes. Put u dash equal to 0. What you will get? Log x is equal to 1. That means x is equal to e. Yeah.
Yes, sir.
Yes, sir.
Good. If x is less than e, if x is less than e, then take log on both sides. Log x is less than log e. Is that okay? Because log is an increasing function. This implies log x is less than 1. This implies 1 minus log x is greater than 0. So let's try to observe on real line. When I say x is less than e, that means x is somewhere here on the left of e. So if your x is on the left of e, 1 minus log x is positive. So u dash is also positive. Do you agree with this?
Yes. Yes,
Ah.
sir.
Yes,
So
sir.
you have a function whose derivative is positive. So what can you conclude about that function? Function is increasing.
It's
Increasing.
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 Yeah, it is increasing. So on the left, it looks like increasing like this. And if you have x is greater than e, then you'll end up getting u dash is less than 0. Is that okay? So on the right, it decreases. Is it okay? And at e, it has a local maxima, this function. Yeah. Now look at the sequence, terms of your sequence. Here you have 0, here somewhere 1, here somewhere 2, then here somewhere 3, 4, and so on. So on the left of e, it is increasing function. It is increasing function like this. So at 3, first two terms are increasing, and third term onwards it decreases. Is that okay?
Yes, sir.
Yeah. So it is neither fully increasing nor fully decreasing. So it is not monotonic sequence. So sometimes this trick also helps while checking whether sequence is monotonic increasing or monotonic decreasing. From the expression of the nth term of sequence, we try to identify a function and then we compute its derivative and see whether it is increasing, decreasing. Using that, we try to conclude about monotonicity of your sequence. Is it okay for all of you?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, very good. Let's look at one more problem. This this is from 2023 question paper. You want to compute limit of this limit of the sequence. So that means limit of the sequence exists. The question says compute the limit. That means limit of the sequence exists. So let us say L is equal to limit of the sequence. Then you take log on both sides, the usual trick. You'll get something like this: log of 1 plus 1 by 2 raised to n, and so on. 1 plus 2 0 2 3 raised to n upon n. What kind of form is this? Is it possible to apply L operator? Yes, yes. Very good. Is it infinity by infinity form?
No, sir.
No,
It's
sir.
0 by
0 upon infinity.
0.
Zero. Numerator ka limit. What is the limit of numerator?
Infinity.
0.
So you break this like this into limit n tends to infinity of 1 by n. So this limit is 0 and this limit is also 0. So L is equal to log L is equal to 0. So L is e raised to 0. That's 1. Correct. Is it okay?
Yes, sir.
Yes, sir.
What about this? Which option is correct?
C.
Yeah. All of you agree with C?
Yes, sir.
Yes, sir.
Yes. Very good. There are 3 subsequences which converges to same limit, and these 3 subsequences constitute the full sequence. So that's why your full sequence also converges to Z naught. So any of its subsequence will converge to Z naught. Yeah. Good. Yeah. This is the question from last year paper. The given information is there is a n-sided regular polygon. It is circumscribed by a circle with radius Rn, and there is a incircle whose radius is small rn. Then we want to compute this particular limit. So since there are 4 finite options, that means this limit exists. This limit exists. Let us say L is equal to limit of the sequence. Let us say L is equal to limit of this sequence. In the same trick, you have to apply log on both sides. You'll get something like this. N square into log of Rn by Rn. Okay. After this, what can be done? What we can do after this? Can you tell me where does Rn by Rn goes? Is it a convergent sequence? Rn by Rn? Capital Rn by small rn?
No, sir.
No means whether you want to say it is not convergent or something else.
Not convergent, sir.
Okay. What about others?
Sir, is the limit is 1?
Limit is 1. Okay. What about others?
Not convergent.
Okay, not convergent. Do you understand what is capital Rn and what is small rn? For example, you take a circle, sorry, triangle. N is equal to 3. Then there is a circle which goes through all 3 vertices of this triangle. Radius of this is an equilateral triangle. We are considering regular n-sided polygons. Equilateral triangle. So radius of this outer circle is capital Rn. Is it okay? And there is another circle. There is another circle which touches all 3 sides of this triangle. Radius of this circle is small rn. In this case, it is R3. And then you have to consider the same thing for n equal to 4, n equal to 5, n equal to 6. If you take a square, then you have outer circle and inner circle. And you have radius of outer circle. You have radius of inner circle. R4 upon R4. Then you have pentagon, hexagon, and so on. What do we know about this regular n-gon? As the
सर
number of
as
side
side
increases. Yes.
सर as जो sides जो है as
हाँ.
sides increases also the outer radius and inner radius becomes equal, sir,
Yes.
because
Yes. Yes. Continue.
because number of sides increases, so it becomes a circle.
Yes.
So
Yes.
circle.
So all of you agree with the argument?
Yes, sir.
So as your n goes on increasing, the regular polygon PN will approach towards a circle. So circumscribed circle and inscribed circle both will be same. So your Rn and Rn becomes approach to same number as n tends to infinity. So their quotient will approach towards 1. Is that okay? So the quotient will approach towards 1. Okay, so Rn upon Rn, a limit exists and it goes to 1. So where does log of Rn upon Rn goes? Go to log 1? Yes, 0.
Zero, sir.
So, yeah, so this is something like 0 and this is something like infinity. How do we tackle such kind of limit?
You can write
Sir,
it
we
as
can
log
take
by
log
1 by
of
n
R
square.
into Rn by 1 by n square.
Yeah. You need to convert it to either infinity by infinity or 0 by 0 form. So suppose if I convert into 0 by 0 form. So what I'm going to get? Log of Rn upon Rn divided by 1 by n square. Now it becomes 0 by 0 form. So we can apply L'Hopital rule. Is it okay? Yeah,
Yes,
Okay.
sir.
good. So I need to differentiate numerator. Also, I need to differentiate denominator. So when I try to differentiate the numerator, what I'm going to get? This is the first into derivative of Rn upon Rn. इसका derivative I need. And the denominator derivative is minus 2 by n cube. What you will do next? So you need to compute. Now it's not possible to go ahead because I don't know what is Rn upon Rn. I don't know what is capital Rn. I don't know what is small rn. I don't know their quotient. So how can I differentiate? So I need to compute, or at least I need to compute this quotient. If I am not able to compute what is Rn and what is small rn, but I need to compute their quotient. Okay, so let us come back to our diagram. This is your n-gon. This is your triangle. All sides are equal. Regular n-gon. Draw a perpendicular from the center of the circle. So this is my capital Rn and this is my small rn. All of you agree with this?
Yes, sir.
All these triangles are isosceles triangle. Okay, so
Yes,
that's
sir.
a capital Rn and this is
Yes,
small
sir.
rn. Yeah. So do I know this angle? ये angle पता है मुझे. Do I know this angle?
Theta by n. Sir, 360 by n.
360 upon
360,
2n.
360 upon 2n. See, there are how many triangles? There are n triangles.
In number of triangles.
So this total angle is 2 pi by n. And this half of that is pi by n. Yeah, all of you agree with this?
Yes, sir.
So
Yes,
what
sir.
is cos pi by n? What is cos pi by n in the small triangle? In the small triangle, what is cos pi by n? Adjacent
Small
upon hypotenuse?
Rn by
Yeah,
It's
capital R.
Rn upon
yes.
small Rn upon capital Rn.
Small rn upon capital Rn. So that means capital Rn upon small rn is 1 upon cos pi by n. Is it okay?
Yes,
Okay,
sir.
so I haven't computed what is capital Rn. I haven't computed what is small rn, but I have computed the ratio. It is 1 upon cos pi by n, and that is what required for the further computation. So I can carry on the computation. I will get something like this. This is cos pi by n into derivative of cos this minus 1 upon cos pi by n whole square. Huh? Into derivative of cos pi by n minus sin pi by n into derivative of pi by n minus pi by n square into 1 upon minus 2 by n cube. So what you will get after cancelling is equal to minus 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 minus. So that plus that goes off. What you're left with? 1
Sir.
upon
Tan
yes.
Deepak sir,
pi upon n.
Yeah.
sir, we have another session lined up after this. Thank you.
Okay. 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 So all of you can try further and tell me the answer in the next session. Is that okay for all of you?
Yes, sir.
Okay, sir.
It's fine. Thank you so much, sir.
Sir,
Okay.
can you
Okay.
show the problem so that we can take a screenshot?
Yes, here it is. It's from 2024. Is that okay? So can I stop sharing now?
Okay, sir.
Yes, sir.
Thank you, sir.
Thank you. So we'll meet next.
Thank you, sir, for this engaging lecture. I request the participants, if in case you have doubts, to address them in the next coming session of Deepak, sir. We shall move on to the next session quickly now. For the next session, we have Dr. Ranjan Khatu, sir, who is an assistant professor from in the Department of Mathematics at Arts, Commerce and Science College, Lanja, which is in Ratnagiri. With the more than 13 years of experience, teaching experience, sir also creates and posts educational videos on YouTube. So I definitely recommend everyone to check them out. It is a privilege to have sir as a resource person for this workshop. I now heartily invite sir to uh, engage the session. Thank you.
Thank you, madam. Okay, I'm going to share my screen. Am I audible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Is it visible to all?
Yes, sir.
Okay. See, my topic is integral calculus. Okay. So I have taken some problems from last year question papers of IIT JAM examination, and we are going to discuss. See, we are going to cover problems on double and triple integration, change the order of integration. All these are points of syllabus of IIT JAM examination. So I've taken problems from that and we will start to solve. Okay. So here I consider all students are from final year BSc class, right? Or you have completed your TY last year?
Yes, sir.
Okay. So you have in Mumbai University that double triple integrations are already covered in semester 5. Okay. So by assuming that part, I'm going to start problems. All of you are comfortable with double and triple integration?
Yes, sir.
Okay. Okay. So I will keep that thing in my mind while teaching that point. Because if I start to solve from the beginning, okay, if I explain the double triple integration from the beginning, we can cover hardly 3 or 4 problems in a lecture. So I most of are from TY. So you already know double, triple, change the order. So let us solve these problems. Okay, so this is the first problem. So we have this triple integration we have to solve. V is a region given by, okay. Just a minute. So let me write I is equal to triple integration x square y plus 1 dx dy dz. Okay, so we can easily solve triple integration if you know the limits. So here our task is to find limits of those triple integration. So for that we should know the region, then we can find the limits. Okay, so let us try to understand the region. So what they have mentioned here, V is a region given by. So they have given some inequalities. if you have inequalities, it is difficult to draw the region. So I will replace them by equality. So we will come to know the surfaces and curves, right? So region is bounded by x square plus y square is equal to 1. So will you tell me this is equation of what?
Circle.
It's a circle.
Yeah. It's a circle in xy plane. Am I right?
Yes, sir. With
In
the
xy plane.
center in
Next.
origin and radius 1.
Yeah. Center. What did you say? Center.
Center at the origin and radius 1.
Yeah. Radius 1. Okay. So actually the triple integration, that means we supposed to draw 3D diagram. X-axis, y-axis, z-axis. So we have a circle in xy plane with center 0, 0, radius 1. So it will look like this. Am I right?
Yes, sir.
Okay. So let us consider the next inequality. We have this one. Okay, but I will replace it by equality. So first I consider z is equal to 0. Z is equal to 0 means what?
It's xy plane.
XY plane.
It's xy plane, right? So z is equal to 0 indicates xy plane, and z is equal to 2 means
It's a plane at
Z
which
axis.
z value at 2.
it's a plane parallel to xy plane. Am I right?
Yes, at
And
a
it
height
cuts
of 2.
z-axis at point 2. Getting? So that means actually we get a cylinder here having some height 2. Getting?
Yes,
We get
sir.
a cylinder here, right? Okay. So generally, when you have x square plus y square is equal to r square, it represents a circle in xy plane, but we have a 3D diagram. It represents a cylinder whose base is that circle. Okay, so I got this kind of cylinder. See, when you have cylinder, when you have paraboloid, getting? And when you have cone, if you have these three geometrical figures, then we go for cylindrical coordinate system. If you convert a problem in cylindrical coordinate system, we can easily solve. So do you know the substitution required to convert a problem in cylindrical coordinate system? Can anyone tell
Yes,
me?
sir.
What is
Yes,
it?
sir. It's x r cos theta and y is equal to z, r sin theta and z is equal to z. Z will remain same.
Yes, Z will remain same. So if you use this substitution, the problem will be converted into cylindrical coordinate system. And what about dx, dy, dz?
R dr d theta dz.
R, dz, dr, d theta. Okay, so I'm going to convert a problem into cylindrical coordinate system. Okay, so let us convert the equations also. We have this equation x square plus y square is equal to 1. Let us convert it into cylindrical coordinate system. That means simply you have to put x is equal to r cos theta here and y is equal to r sin theta here. So if you put, what will you get?
It's just r square is equal to 1.
Yes, since cos square plus sin square 1, so r square is equal to 1. By taking square root, you get r is equal to 1. Am I right?
Yes, sir.
Okay. So as you know, in cylindrical coordinate system, we have converted a problem into variable z, variable r, and variable theta. So obviously, I want the limits of z, r, theta. Can anyone tell me what will be the limit of z?
It's 0 to 2.
0 to 2.
Yeah, it is clearly given in a problem. Z varies from 0 to 2. You can easily see here. They are given in a problem. Getting? No need to worry. What about r?
0
0
to
to
1.
1.
Yeah, 0 to 1. Okay. So here the picture is clear to us, but see, let us try to understand. Actually, we have a strip like this. Okay. We have a strip like this. If you draw in XY plane, let me draw a very small figure here. So we have in XY plane, we have a circle, which is the base of that cylinder. And we have a strip like this. Get it? which varies from 0 to 1, 0 to 1, okay? And our target is to cover the entire cylinder. So this strip should be rotated by how much degree?
2 pi.
5.
360 degree. That means theta varies from 0 to 2 pi. So that's why the limits are ready. So let us solve the integration. So here generally we solve the integration with respect to z first. So I'm writing the limits of z here, limits of r, and last limits of theta. Okay, so let us see what is the given integral. X square plus, see what we have, x square y plus 1. Let us put the values. X is what? R cos theta, na?
Yes, sir.
And y r sine theta. So what will I get?
It's r cube cos square theta into sine theta plus 1.
Sine theta plus 1. And what about this dx dy dz?
It's r dz dr d theta.
Put this value. R dz dr d theta. So first we will integrate with respect to z, right? We have to solve the inner integration first. Am I right?
Yeah.
So is there any z? Is there any z?
No,
No.
sir.
So it is constant, no?
Yeah.
It will come outside. So I'm taking the product also. R raised to 4 cos square theta, sorry, sine theta plus r constant 0 to 2 dz dr d theta. Integration of dz,
It's z only.
z only by putting upper and lower limits.
It's 2.
Sir, 2.
2, no? All of you are getting the point, no?
Yes, sir.
Okay, shall I write 2 directly outside?
Yes, sir.
Yes, sir.
0 to 2 pi 0 to 1 r raised to 4 cos square theta sine theta plus r dr dz. Can anyone tell me the integration with respect to r?
Yes,
R
sir.
power
It's
5 cos square
r
theta
to
sin theta by 5 plus r square by 2.
Okay. Let us put upper limit, lower limit. What will you get?
it's 1 by 5 cos square theta sine theta plus 1 by 2.
Okay. By putting r is equal to 1, you will get same. By 5 plus 1 by 2. If you put 0, you will get same. Okay. So how to solve it further?
Sir, shall we substitute cos square theta is equal to 1 minus sine square theta? Because we have sine cube theta
Yeah,
is
yeah.
equal to 4.
Okay. See, before that, you are right actually, huh? I don't know your name, but you are right. But see, what will I do? I will take the separate integrations. Okay. Will it be better?
Yes,
Yes.
sir. It will be easy.
2 will get cancelled, 0 to 2 pi. Okay. So I'm sure the second integral anyone can solve easily, right? So
Sir, you.
sorry. Okay.
It's
See,
fine.
what about the first integration? See, multiple ways are there to solve the first integration. Getting? See, I will tell you the technique. So generally, what I do when you have the limit 0 to pi by 2 and when you have cos and sine, I go for beta function. Agree with me?
Yes, sir.
Okay, but the problem is
Yes, sir.
that here we have the limit 0 to 2 pi. So that technique will not work here. Agree?
Yeah.
Okay, but see one more way is there. 0 to 2 pi cos raised to m theta sin raised to n theta d theta. You know the general formula is equal to 0 if m is even and n is odd. Getting?
Yeah.
So power of cos is 2, which is an even number. And power of sine is not there, which is one odd number, right? So
Yes,
that
sir.
technique works here, and the value of first integration is 0. But what about the second? Theta 0 to 2 pi.
2 pi, sir.
Yeah, answer
2
will be
pi.
2 pi or 2 pi, 2 pi. Yeah, right. So let me check the options here, 2 pi. So yes, this is the correct option. Okay.
Sir,
Huh?
sir, what if the aim is odd and n is even?
See, there are certain formulas if m and n are equal, if m and n are distinct. Getting? So those formulas are there. With the help of that, we can easily find.
Okay, sir. Thank you.
So see, let us go to the second problem. So what we have, I is equal to integration over g ln x square plus y square upon x square plus y square dx dy. So in this problem also, we are facing the same problem. They have not given the limits. They have mentioned the region. With the help of that, I will find the limits first and easily will get the answer. So can anyone tell me how to find the limits? What will be the region? See, you can easily see we have two inequalities. Agree?
Yes.
We will consider them one by one. And as I told you earlier, first we replace inequality by equality. So what will I get here?
Unit, sir.
Unit
We will
circle.
find.
Yes. So it's a circle. Center 0, 0. Radius 1. Agree?
Yes, sir.
So we have a circle, center 0, 0, radius 1. And let us consider the second inequality.
X square plus y square is equal to e square.
Yeah. So this is again circle. See, I'm comparing with a standard equation. X square plus y square is equal to r square. Getting? So this is the equation of circle with center 0, 0, radius r. So what is its radius?
E, sir.
E, you are right, E. So we have two concentric circles, first having radius 1, second having radius E. Okay. And the region is bounded by these two circles. So generally when we have circles, we go for polar coordinate system. Getting?
Polar coordinate.
Exactly,
Yes,
exactly.
sir.
So how to convert a problem in polar? There is a substitution, no?
Yes, sir.
X is equal to r
Previous
cos
one.
theta, y is equal to r sin theta.
X is equal to
R cos theta and y is equal to r sin theta.
r sin theta. And what about dx dy?
It
R
is
dr
converted
dt.
to r dr theta.
Okay. Okay, very good, very good. See, yeah. So let us convert those equations in, okay, there is no space to write. Just a minute. Okay, so let us rewrite these equations in polar form. This equation, okay, first equation. X square plus y square is equal to 1. Let us put x is equal to r cos theta, y is equal to r sin theta. So what will you get? R square. Getting the point? Cos square plus sin square is 1. So
Yes,
that
sir.
r square is equal to 1. That means r is equal to 1. What about the second equation? In a
We will
r is
get
equal
r
to
is equal to e.
E.
R is
So
equal to
inner circle having equation r is equal to 1. Outer circle having equation r is equal to E. Okay. So in polar form, we draw strip like this. Strip like this. See, that strip always starts at origin, huh? It always starts at origin. But this part of strip lies outside this region, so that's why drawn by dotted lines, and this is region actually. And the strip rotates in anti-clockwise direction and it covers the entire region. Getting the point?
Yes, sir.
Okay. So what will be the limits of r and theta?
The limits for R is
R is
1
1,
to E
1 to E. Theta
Yeah.
is
and
0
the
to
theta
pi.
will be 0 to 2 pi.
Theta will be 0 to 2 pi. Okay, so let us solve the integration now. I is equal to, always we solve the inner integration with respect to r, 1 to e and 0 to 2 pi. Okay, so let me check the function. What is the function? Log ln x square plus y square. But what is x square plus y square in polar?
It's only R square.
R square, x square. If you put x is equal to r cos theta, y is equal to r sin theta, it will be converted into r square. In denominator, r square. Dx dy should be replaced by r dr d theta. Next step. How to solve it further?
Sir, we can
R
simplify.
Mhm.
Yeah, we can take the 2 out of the logarithm and it will be ln R upon
Okay.
R.
Hmm.
And then we can substitute ln R by T.
Okay. Okay, I will
Then
follow your technique. Okay. So what you are saying, putting, you need to put, right?
yes, sir.
Okay. Log R is equal to T.
T.
When you put, you're
Then the
supposed to take derivative.
derivative will be 1 by R dr, which is same as dt.
Okay. See, you need to change limits also.
Yeah.
What is the
When
lower limit?
for R is equal to 1, the T will be 0.
Okay, R is equal to 1. T is equal to, I'm putting it here, right? For
Yeah.
this
Yeah.
substitution. ln 1,
It
which
will
is,
be 0. It
okay.
will be 0. And for R is equal to E, T will be 1.
Okay, okay. So I is equal to 0 to 2 pi. Limits will be 0 to 1, as you said. And 2 log R is equal to T,
It's T.
right? And
Yeah.
this 1 by R dr will be replaced by?
dt.
Okay.
Then d theta.
Okay, okay, okay. So how to solve it further? Can anyone else try for it? 2 will come outside. 0 to 2 pi. Please. It's quite simple now.
It will
Yeah.
be 2 into t square by 2. 2 will get cancelled and it will be only t square.
Limits 0 to 1. Okay.
This is 0 to 2 pi d theta.
Hmm.
And it will be
Answer will be
2 pi.
okay. So let us check their answer in options. Okay, let us check this answer in options. 2 pi. Yes. So we have,
In B.
yeah. Okay, let us move further. So can anyone tell me how to solve this one? Any idea?
Yes,
Sir,
sir.
can you show me the last answer for a second? Thank you, sir.
Welcome. What about this? Okay.
It's a mixed concept of vector calculus and integral.
Yeah.
Actually, it's I don't remember the for theorem's name.
Okay.
But it says it can be represented, the y dx plus 2x dy can be represented as y I cap plus 2x j cap dot
Okay.
d dx I
Okay.
cap plus dy j cap.
Okay. Okay.
And
Hmm.
then we can convert it into a double integral.
Hmm.
Mm,
So,
uh,
which theorem exactly we used to convert this problem in double integral?
yes, sir, I
Do not
forgot
remember.
that.
Anyone else?
The Green's theorem.
Yeah, very good, very good. See, so when you have the problem in xy plane and when you have p dx plus q dy, this, okay, the problem is this format, single integration with two variables, right? So only that Green's theorem has that magic to convert into two variable, double integration, okay? So what it says, deba q by deba x minus deba p by deba y, am I right?
Yes, sir.
Dx dy. What is p here? What is p?
It's y.
Y. P means multiple of dx, right? And what is
Yes.
q here?
2x.
Exactly 2x. Exactly. Q is a multiple of dy. Okay. So yes. So I supposed to take derivative. Okay, let me write it again. Integration over c. Y dx plus 2x dy is equal to, this theorem says double integration over s, daba q by daba x. That means derivative, partial derivative of q with respect to x. Can anyone tell me?
Sir, it's 2.
Exactly, 2. And what about daba
It's
p by daba
2
y?
and 1.
Yes. Dx dy. 2 minus 1? 1. So you get dx dy. Agree?
Yes, sir.
Okay. So let us try to understand the relation between C and S. C is a curve, closed curve. C is a closed curve, getting, and S is the region bounded by C. So this is the relation between C and S. Okay. So here, whatever we have got in this step, there is no any function. That means it represents area of S. Agree?
Yes, sir.
Okay, area of
Sir,
S.
can you
There is,
repeat?
okay. See, I'm telling this relation between C and S. C is a closed curve and S is a region bounded by that closed curve C. Get it?
Oh, okay, sir.
And the one more important thing, that there is no any function, only dx dy is there. It means it gives the area of surface S. So if S is any standard region, that means circle, rectangle, triangle, getting? So in that case, we can directly using the formula, which we already studied in our school. Okay. So using those formula, we get the answer. But otherwise, if the region is complicated, we need to find the limits and solve the problem. Getting? So let us see what is the region R. Instead of S, they have mentioned R. Huh? This is the only difference. They have mentioned region R. Okay. So what have they given? Y bounded by this minus 1, 1 and x bounded by this 0 and 1 minus y square. Agree?
Yes, sir.
Okay. So region is bounded by 4 different curves. So to find them, we replace inequalities by equalities. So the first equality is y is equal to minus 1. Second equality, y is equal to 1. Getting the point?
Yes, sir.
Okay. So first is y is equal to minus 1. Second is y is equal to 1. Third,
It's
Is
x
it
is
equal
equal to
to
0.
0?
and
X is equal to 1 minus y square.
okay. Just a minute. See, x is equal to 0 and x is equal to, what did you say? 1 minus y square. So this is x-axis. This is y-axis, right?
Yes, sir.
Okay. So x is equal to 0 means this is equation
It's
of
y-axis only.
y-axis. Region bounded by y-axis. This is equation of what?
Circle.
Circle.
Parabola.
No, it's a parabola.
Yeah. See, if in an equation, power of one variable is 1 and power of second variable is 2, it represents a parabola. Getting the point?
Yes, sir.
Yes, sir.
Okay. So when you have both variables power 2, getting now? In that case, it can be a circle
It's a
or it
circle.
can be an ellipse. Getting?
Hmm.
Or it can be a hyperbola also.
Hyperbola.
But see, power of one variable is 1, power of second variable is 2. That means 100% it is a parabola. Okay. See square having a negative sign. We never have this. So I will shift y square on this side and x on that side, 1 minus x. It looks better now. Agree?
Yeah.
Yes, sir.
Power of x is 1 here. That means the parabola is symmetric about x-axis. Getting the point?
Yeah.
Yeah.
Symmetric about x-axis. That means either in this way or in this way. But see, x has minus sign. X has minus sign. Can you see x has minus sign?
Yes, sir.
That means the parabola opens in a direction of
Yes, sir.
negative x-axis. You are getting the point? Since it has minus sign. Okay. See, and definitely this parabola is like this. It cuts x-axis at some point. So let us find this point of intersection. So for that, I'm going to put x is equal to 0. Sorry, y is equal to 0.
Y is equal to 0.
If you have put y is equal to 0 here, you will get x is equal to 1. That means the parabola cuts x-axis at point 1 here. So the parabola will be like this, getting like this. Here 1 we have.
Yes, sir.
But this parabola cuts y-axis also at some points. Okay, definitely now. So it cuts y-axis also at 2 points here and here. So let us find them by putting x is equal to 0. I am putting x is equal to 0. So you will get y square is equal to 1.
And the
See, what
y
will
will
be the
be
values of
minus.
y? If y square is 1, values of y will be
It's minus 1 and 1.
plus minus 1. That means it cut y-axis at point 1 as well as minus 1. So now the picture is clear to us. The parabola will be, sorry, like this. Am I right?
Yes,
Yes
sir.
or no? Okay. As well as we need to consider these two equations also. Y is equal to minus 1. It represents y is equal to
It
minus 1.
it
A line.
represents a line parallel to x-axis having
Yes.
x is equal y is equal to minus 1.
Yes, that means the parabola, sorry, a line parallel to x-axis passes through y is equal to minus 1. Getting? And what about the second y is equal to 1? It is also a same, parallel line. Line parallel to x-axis passes through y is equal to 1. So we have the line like this. So region bounded by this line, region bounded by this line, region bounded by y-axis, region bounded by parabola. That means this is a given region. Getting the point?
Yes, sir.
Okay.
Yes, sir.
Okay. See, we have to solve this one. So we have two options. Either we consider strip parallel to x-axis or parallel to y-axis. I think it is better to consider strip parallel to x-axis here. So we need to write the limits of x first. What will be the limits of x? Can anyone tell me?
0 and
given.
1.
Sorry.
It's
0.
given.
See, here x is equal to 0, y-axis here. Strip is bounded below by this line. And
1
strip is
minute.
bounded above by this parabola, whose equation is x is equal to 1 minus y squares. So generally what we do when you have a strip bounded below, bounded above, right? Strip bounded below by 0, x is equal to 0. Strip bounded above by this 1 minus y square, x is equal to 1 minus y square. So can anyone tell me the limits of y now?
-1 to
-1 to +1.
Exactly, -1 to +1. Very good, very good. Okay, so yeah. So let us finish this problem. I is equal to -1 to 1, 0 to 1 minus y square, and there was no any function. There was no any function, just we had dx dy. So we can easily solve. Can anyone tell me the integration other than these 2-3 students who are answering my questions? Other than these questions, since everyone should say something. What will be the integration of dx? Now the problem is quite easy.
That's x.
This is x.
Yeah, very 0 to 1 minus y square. Upper limit, lower limits. Let us put upper limit, lower limit. 1 minus y square. If I put 0 to 0. Yeah. Is it an even function?
Yes,
Yes,
sir.
sir.
Yes.
Function, since powers are even, and when you have limits like this, -a2 plus a, and the function is even, then what we do, we write 2
0
0
to a.
to a if the function is even, and if the function is odd, what will be its value?
0.
It will be 0.
Yeah. So when you have this kind of limits, now always go for even and odd function. Within less time, you can solve the same problem. So 2, 0 to 1, 1 minus y square dy. So what will be the integration now?
Y minus
Y
y
minus
cube by 3.
Yeah, very good, very good. Okay, so we'll put the upper limit, lower limits.
2 by 3.
2 by 3. Shall I write directly?
yes,
Final answer?
4 by 3.
4 by 3.
Let us check the option. Yes, 4 by 3 is there. Got it. Very good. Okay, move further. See, this is the next question. So can anyone tell me what we need to do here? See, f of y function is not given. That means definitely we will never get the answer. Since the function is not given, but simply we have to choose which will be the correct option.
We have to trace the graphs
Uh,
and find the reason.
okay.
Then we could change the dy dx. That means the inner integration
Change the order of
dy.
integration.
Yeah, order of the integration.
Okay. May I know you are from which university?
Utkal University, Bhubaneswar, Odisha.
Yeah, Odisha. Okay, so that's why. Actually, in Mumbai University, generally we say it is change the order of integration. That kind of question is this one. Getting? See, I
Yes.
is
Yes, sir.
equal to 0 to a, 0 to x, f of y dy. Okay. So she has already understood what has to do. But see, for remaining students, I'm telling again.
Sir,
Sorry?
can you show me the question for a second?
Okay, no problem.
Sorry,
No problem.
can you show me? Thank you, sir.
Okay. See, yeah. See, inner integration with respect to y, agree? And function is not given to us. That means
Yes,
we
sir.
cannot solve the problem. We cannot integrate until we interchange the this integration. Until you change the order of integration. So if you interchange dx and dy, if you can
Yes.
interchange dx and dy, then you can solve f of y will be constant and will go outside. Agree?
Yes.
Okay. So for that, what will I do? I will try to draw the region first. 0, x, 0, a. Agree? Inner
Yes.
integration with respect to y. So these are limits of y.
Yes, sir.
Outer integration with respect to x. So these are limits of x. So the region is bounded by x is equal to a, first equation, x is equal to 0, second equation, y is equal to 0, third equation, y is equal to x. Agree? So the given region is bounded by these 4 lines. All these are lines. Okay. This is x-axis. This is y-axis. X is equal to A. This is equation of what?
A line parallel to y-axis.
Passes through X is equal to A. Agree? X is
Yes.
equal to 0.
Y-axis.
Exactly. Y is equal to 0.
X-axis.
Very good. Y is equal to X.
A
It's a
line
line
passing
with
through
slope
origin.
1.
Straight line passing through origin.
Yeah, line passes through origin. Getting? So you
With
will have the
slope
line like
1.
this. Yeah, slope 1. Very good, very good. Okay. So actually we are familiar with this line, so that's why I'm not going in details. Otherwise, if you don't know how to draw lines, then you're supposed to draw one table. Getting? And you need to find in our, I think 9th standard or 8th standard, we have already studied. There is
Yes.
a unique line which passes through given 2 points. You're supposed to find any 2 points on the line using this table. And if you get the points, you can draw the line. Okay, so the region is bounded by these 4 lines. That means this is a region we have, right? Agree?
Yes, sir.
Yes, sir.
Inner integration with respect to y. Inner integration with respect to what? Y. That means the given strip is parallel to y-axis. Since inner integration with respect to y. But what we want to do, we have to interchange. That means we supposed to consider a strip parallel to x-axis. Okay, then we will get the required thing. So here I'm considering a strip parallel to x-axis. Its equation is y is equal to x. Let me write here. This is y is equal to x. This is x is equal to a. Okay. So strip is parallel to x-axis now. So I should write the limits of x first. And then limits of y. What will be the limits of x?
Y to A.
Very good. Y to a. And limits of y?
0 to A.
Yes. All of you are getting why I'm saying why he's saying 0 to a.
Yes,
So
sir.
here
Yes, sir. It
we have
has
a
actual
C.
point.
We need to find a point of intersection. How to find point of intersection?
We will just put in place of y a because x equal to y.
Yes. See, when we have two curves, suppose this is y is equal to x square and this is x is equal to y square. Anything you can take. And if you want to find a point of intersection, what we do generally, we put the equation of first, okay, curve into the equation of second. By putting first into second, you get the point of intersection. So here I'm putting x is equal to a in this equation. You will get y is equal to a. So this point will be a. So that's why we are saying limits of y from 0 to a. All of you are getting?
Yes, sir.
Yes, sir.
Okay. See, I is equal to, now our strip parallel to x-axis. So that's why I should write dx first, dy second, limits of x, y to a, limits of y, 0 to a. Now we have to integrate with respect to x first. So can I say f of y is constant?
Yes, sir.
Let us throw it outside. F of y will go outside. Y to a dx. What is integration of dx?
A minus y.
It's X. A minus.
Y to a. Let us put upper limit, lower limit. What will you get?
A minus Y.
To a f of y, a minus y dy.
A minus y dy. Let us check the option. If the integration 0 to a, f of y, a minus y dy. Is there any option?
Yes, sir. It is option B.
B, yes, yeah, B. Is the correct option. Okay, so let us move further. What about this? How to solve? Do you think it is easy? Yes, very good. Do you think it is easy? Otherwise, I will move further. Since I have actually many problems, but we have very less time to finish those. So if you feel it is easy, I will move further. Otherwise, I will solve this one. What shall I do? Shall I solve?
No, sir.
No, sir.
Okay, that means you can solve it, no?
Yes, sir. We will solve it.
Yes.
Yes, sir.
Very good, very good. Sure, no?
Yes, sir.
Okay, okay. Okay. What about this? Any idea?
Stokes theorem.
Sure. Sure. Are you sure? See, yeah, you are right actually. When you have this kind of equation integration over C, a bar dot dr bar, generally we go for Stokes theorem. But the problem is that, have they mentioned curve C? Have they mentioned curve C? What is curve C? Have they mentioned?
No, sir.
No, they
sir.
have not given equation of C. If you don't know what is C, how to draw the curves and how to find the limits, that's the problem. You're getting the point? If C
Yes, sir.
clearly mentions C is a circle, C is a triangle, C is a rectangle, whatever. If it is given, then we go for a Stokes theorem. Obviously, okay, so it is in that format, Stokes theorem. But the problem is that they have not mentioned C here. We don't know what is C. Then how can we solve? Is there any other option?
Definition of line integration of vector field.
What is that?
Conservative vector field.
Oh, no. Yeah. The second answer is correct. Conservative, very good. Someone said that definition of line integral, but for
It
definition
will be
also.
part independent, so it will depend on last point and first point.
Exactly. Very good. The field is conservative. Getting? The field is conservative. First, you supposed to write the field. So, can anyone tell me what will be the F bar here? No need to write it. No, shall I write directly? What will be the F bar?
Yes, sir.
2xy plus z square into I, right? Plus x square z plus z plus y plus 2xz How to prove the field is conservative?
कर्ल फाइंड करेंगे सर.
कैसे
If
फाइंड
curl is
करेंगे
zero,
कर्ल? Del cross F bar, na?
Yes, sir.
How we find del cross F bar? By solving
The determinant.
I
I, Z, K,
del
then
X, del
del
L,
upon
Y,
del
and
z,
del Z.
and the value is 2x.
2xy.
multiple of I, multiple of J, multiple of K. Okay. Can anyone help me to solve this one? I.
Yes, sir.
Its derivative with respect to Y.
1.
It's 1
Minus its
minus
derivative with respect to Z.
1.
Its derivative with respect to X.
It will be 2Z.
Its derivative with respect to Z.
2Z.
Okay. What will be its derivative with respect to X?
2x.
Its
Minus
derivative with respect to y.
2x.
So all terms will get
2.
cancelled each other, no?
Yes.
0i, 0j, 0k. Am I right?
Yeah.
Yes, sir.
So we get 0 bar. So curl of f bar is 0. So that's why we say f bar is conservative, right? Okay. So we proved that field is conservative, right? It means the value of integration depends on just endpoints only. That means the value of integration depends on these 2 points only. But tell me how to solve it further.
Now we will find a scalar f.
Yeah.
First we integrate m with respect to x, then we integrate y and x को constant रखेंगे, then we integrate z and take x and y constant. Means phi from x and y, not constant, phi from x and y.
Exactly. Okay. So I will write all these things, whatever you said. Okay. Phi with the potential function, scalar potential, whatever you want, you can say. So f bar is equal to del phi, right? So f bar, that means whatever the given f bar, I supposed to write here. Okay. Del phi means delta phi by delta x. Agree? Delta phi by delta y j plus delta phi by delta z. Okay. Then we compare. Delta phi by delta x is equal to first bracket. Delta phi by delta y is equal to second bracket. Delta phi by delta z is equal to third bracket. Agree? All of you are getting now? What will be delta
Yes,
phi
sir.
by delta x then? Tell me.
Yes, sir.
What will be delta phi by delta x?
2xy plus z square.
Yeah. 2xy plus z square. That means we compare the multiples of I. Multiples of j here, delta phi by delta y. What is multiple of j? X square plus z. So I'm writing delta phi by delta y is equal to x square plus, what did you say? Z, x square plus z. And last one, multiple of k, delta phi by delta z is equal to, what I should write? Delta phi by delta z is equal to
Y plus 2xz.
y plus 2xz. Okay. Then what we do, we have to remove that derivative with respect to x. So we integrate with respect to x. Derivative integration will cancel. If you integrate with respect to x, what will you get here?
2x square y
X
by
square y.
2x square by 2. 2 will get cancelled, right? Y plus xz square plus. So when we integrate, generally we write constant of integration. So I'm writing here psi 1 of yz. Since when you integrate with respect to x, y and z are constants. So that's why we get some function of z. Can anyone tell me phi? That means we have to integrate with respect to y now. This is a derivative with respect to y. We will integrate.
Square y.
Huh?
Square
X
y.
square y.
Square y plus yz.
That's y.
Yeah, plus psi 2
Hi.
of
Phi 2 of
xz.
x comma z.
exactly. And what about this?
yz
Yeah,
Yz
very good, very good, very good.
xz
Psi
square.
plus x
xz
z square
square by
plus psi 3 of xy.
y.
So we have to write phi. Okay, so let us write phi and we have to avoid repetitions. Okay, so in first we have got x square y plus xz square. X square y is repeating here, so that's why I will avoid it. Next, yz, right? Again, yz appears here, so I will avoid it. And xz square, that is also appears again. So plus c. So this is a required function phi. Is it clear to you?
Yes, sir.
Okay. Then integration over c f bar dr bar. That means whatever the given integral will be integration over c del phi. F bar is del phi dr bar. Derivative integration will get cancelled and we have simply phi with limits. With limits. What are the limits? minus 1, 0, 1, minus 1, 0, 1, and upper limit 1, 1, minus 1. 1, 1, minus 1. So phi I'm writing here. Phi is x square y plus xz square plus yz plus c minus 1, 0, 1 and 1, 1, minus 1. Can anyone tell me the next step?
Put the values.
Yeah, simply we have to put the values. First, we put the upper limit. X is equal to 1, y is equal to 1, z is equal to minus 1. Agree?
Yes.
Minus, we put the lower limit. X is equal to minus 1, y is equal to 0, and z is equal to 1. So by solving, we will get the answer. And definitely we'll get answer from one of these options. Okay?
Yes, sir.
Okay, so it's quite simple. See, it's 8:15, and actually I have one more meeting at 8:15, and I'm the host of that meeting, so I'm supposed to start at the sharp time. So I hope all of you understood. If you have any doubt, you can ask here. Many problems actually I had planned to finish, but
Sir,
huh?
sir, last question answer. Can you show the last question's answer?
Which one? This one?
No, sir, the previous one.
Okay. You want the
Only
answer
the
of this
answer.
problem? Huh?
Only the option, sir. Only which is the correct option.
You want the answer? Okay. So which one is correct option? This 28/9.
Okay, sir, we can solve.
Okay, sure. Do you want some more problem? You can take a screenshot if you want this problem.
Yes, sir.
Yes, sir.
Take a?
Yes, sir.
Yes, sir.
Okay. It's quite simple. You can easily solve this one. Okay.
Yes, sir.
Sir.
This one also.
Yes, sir. Yes, sir. Yes, sir.
Okay, that's it. Actually, I had planned to finish 10 problems, but we couldn't. No problem. So remaining problems are parallel. You can try for it. Okay, it's little bit tricky, but I'm sure you can. You will get the answer. Okay.
Thank you.
Okay, if you have any doubt, difficulty, you can approach to me, madam, or I will share you the email ID. Okay, so shall I stop this sharing now?
Sir, I have a query.
Huh?
Sir, where I can get the recorded videos?
You need to ask organizers actually. You need to ask to organizers, huh?
Yes, sir.
I
From the
have no idea about it.
starting of the session, ma'am told us that you have a YouTube channel and you shared educational videos there. Can
Yeah.
we have that YouTube channel account name, please?
Yeah, Ranjan Khatu. It's my name, Ranjan Khatu.
Okay.
Many problems actually I have solved there, more than 100. So we'll get this part there. Okay, as well as I've covered complex, power series, and I think there are more than 1300 videos there.
Yes, sir, I usually.
Okay. Okay. So shall I stop sharing now since I have one more meeting as I told you?
Okay, sir.
Yes.
Okay. Okay. Thank you. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, sir. Thank you for graciously accepting our invitation and as a resource person in this workshop. I'm sure that the students might have benefited from your session. I request the participants to kindly fill up the feedback form which is shared in the chat box. on today's session by Ranjan sir. And for any queries that you have, you may mail to us on the email ID that we have provided in the brochure. The Zoom link for the next day's session will be updated in the doc file. So kindly keep checking that. Once again, thank you for attending this session, this workshop. Thank you.
Ma'am, where can I got the previous class recorded videos?
We shall get back to you on that later, like after a day or two. We'll get back to you on that.
Okay, thank you, ma'am.